So I'm having 6 lines of data here. I want to create a data set. Now I'm writing a program to create a data set now. I am writing data set name DS1, semicolon. Do you require infile statement here?
No, sir.
No, sir.
No, sir.
No need, sir. So I'm writing an input statement. I want to have ID, name, character data, dollar symbol, age, sex, character data, dollar symbol, then the salary, and semicolon. Then I'm writing the data lines, or you can also write the cards. Now, after end of that one, I told you if you want, you can keep a semicolon, or directly you can write the run also. Now, I'm selecting this program. I'm selecting this program. I'm executing this program. If I go to the libraries, if I go to the work library, now in the work library, we can find the data set DS1. If I open this data set, now we can find 5 variables and 6 observations. But in the real time, in general, whenever you execute the program, please do not go to the data set and open it. First, whenever you execute the program, please go to the log window. In the log window, now this is the information that you can see. The code, what we have written, now that is in black color. Now, when the program got successfully executed, we will get the nodes. The nodes will appear blue in color. Please read the nodes that what we have. Based on that, try to understand what are the nodes that we have here. Can you see the first node that we have? The data set work.ds1 has 6 observations and 5 variables. Now, in the next line, we have a data statement used the real time 0.11 seconds and the CPU time 0.01 seconds. That means in 0.01 seconds time, it executed the program and it has created a data set called DS1. So not even 1 second, now 10th part of 1 second, not even 100th part of 1 second. In 100th part of 1 second, it created a data set. Now, in today's class, when I execute the program, when I execute this program, in the 0.01 seconds, what exactly happened in the backend? I want to check that one. What exactly happened in the backend when you execute the program? In this time, when I execute the program in 0.01 seconds time, it created a data set. I want to know what are the events occurred during this 0.01 seconds time. So in today's class, we are going to discuss about that process, and that we call it as a back-end process. We call it as a back-end. So what exactly happened? Now, if you know the back-end process, from today onwards, if you got an error in the log window, so that you can read that error, by reading that you can understand that error, so you can rectify that one. You can debug that error on your own. Okay? Not only to understand that programming code, in the real-time interview point of view also, interview point of the way, which is very, very important, which is the back-end process. Okay? Now, we'll discuss what exactly happened. Now, I told you, when I write a program like this one, we select the program, and as soon as you select the program, what you will do, you will click on the run button or submit button, or otherwise what we will do, we click on that F3 button. Isn't it? Now, when you click on the F3 button, the program will be submitted. what exactly happens in the backend? When you submit the program, first it is going to check for syntax error. If you have any syntax error, it is going to check that error first of all. What do you mean by syntax error? Do we have any spelling mistakes? Or do we have any semicolon errors? So it is going to look for that one, spelling and semicolon errors. If you have any spelling and semicolon errors, those errors will appear in the log window and that will appear red in color. Syntax errors you should not have in the real time. If you have a syntax error, you need to rectify that one and you should execute the program again, and otherwise they will not accept our code because the first thing they're going to check is our log window. In the log window, you should not have any syntax errors when you open that log window. Understand? Say for example, in our program, you do not have any syntax errors. The program got successfully executed. Then the next step. So whatever the program, say for example, when I execute this program in the backend now, you know what is going to happen? There is going to be in the backend, there is going to be a concept called word scanner. This word scanner will cut your programs into number of executable words. It will split into, or it cleaves into, it splits into words, small words, and now these words will be the splitting into words, and in the real time, technically each word we call it as a token. So splitting the program by the word scanner into number of words or number of tokens, the whole process we call it as a tokenization. What do you call it as a tokenization? What do you mean by tokenization? Cleaving or splitting the program into number of executable tokens, executable words. And each word is called as a token, and the process is called tokenization. Why the tokenization should occur? What is the use of tokenization? We read the code in SAS window, editor window here, in SAS language, SAS programming language. But when you execute the program, what will happen? In the backend, the program will be get converted into C language. The program will be get executed in the C language. And when the program executed in the C language, you'll get the result in the C language. Then the result will be converted into SAS programming language, and you'll get that output that what you could able to see. So that means they developed this SAS software programming language on C and C++, C and C++. So the program should be get executed in the C language. So that's why the program is going to be get split into number of tokens. Could you able to follow everybody?
Yes.
Okay. Once the program has been, broken down into number of tokens, from here onwards, we can divide the total process into two important steps. Whatever the total process that we have, we can divide the total process into two important steps. The one is called as a compilation phase. The first one is called as a
Hello, sir. Hello.
Yes.
Sir, many students are not able to join. Once check the lobby, sir. They are doing messages in group.
Unfortunately, I do not have that admin, this thing.
Okay.
So I think the stances admin should allow them to join.
Okay.
Can we wait for them?
Yes, sir. They are waiting from 10 minutes, I thought.
Okay, I don't know about that one. Yeah. Okay, we'll wait for some time. Would they able to join? I think we have the number now 137.
So they are saying that they are not lifting the call.
Mhm.
Sir,
Yes,
C language part మళ్ళీ చెప్తారా సార్ టోకనైజేషన్?
sure. I'm waiting others to get joined.
ఓకే సార్.
Manjari, did you join? I think no, not yet, right?
So they joined, sir.
Everybody joined?
Join.
So just now they are admitted.
They are
Okay.
admin. Yes.
Okay. In case if you missed out what we started discussing in today's class, this is what we have discussed. You know, I'm trying to execute the program. I have written a program like this one. I'm taking few lines of in-stream data. So I want to create a data set. When I select the program, when I'm clicking on the submit button or F3 button, the program will be get executed. So as a result, in the work library, we will get a data set. We always tend to try to open the data set to check whether we have the data or not. But it's always better whenever you execute the program, instead of opening the data set first, please go to log window and check if you can find any information. So I told you in the previous classes, I will debug the program in future. I will explain the log window in future. Today, I'm trying to explain the log window. So log window is going to give so much of information. By reading the log window, if you have any error, you can identify that error and you can debug that error. But whenever you execute the program, we can find two types of informations. The code that what we submitted is in black color. And when the program successfully got executed, we can find the notes like this one. Okay. And the notes is saying, please try to read the notes. It's always better to read the notes and try to understand. The first note that we have, the dataset work.ds1 has 6 observations and 5 variables. So that means we created DS1 dataset in the work library and it has got 6 observations and 5 variables. That is okay. Now in the next line, the data statement used the real time 0.02 seconds and the CPU time 0.00. So that means almost in 0.00 seconds time, it has created a data set. Now, in today's class, what I am going to do is, I'm going to explain what exactly that happens during this 0.002 or 0.00 seconds time in the backend. Because We are going, even with 2 to 3 years experience also, in the real time, you will get the questions from today's topic. Not only interview point of view, understanding the SAS programming language, understanding that errors is very, very important. Okay, now I will explain that one. So whatever that happens, just 0.02 seconds time. And that process in today's class, we are going to discuss it as a name, back-end process. That means what exactly happens in the back-end when you execute the program. Okay, so that we are going to discuss in today's class. Now, when I select this program, okay, when I execute this program, now how we are going to execute the program? Yes, as I said, we are going to click on that F3 button, or we are going to click on the run button. When you submit the run button, the program will be get executed. The first thing that it is going to do is it is going to check for syntax error. What do you mean by syntax error? Syntax errors are nothing but spelling errors, spelling errors, or semicolon errors. It is going to check if you have any semicolon or spelling error. If you do not have any spelling error or semicolon error, you have a spelling or semicolon error that will appear in the log window. It will appear red in color. In the real time, you should not have a semicolon or you should not have a red color error at all. If you have, somehow you have to rectify that one. Now, just imagine you do not have such errors. Even though you have error, you rectified that one. From here, keep your, and you will rectify that error. When you rectify that one, now the next step will take place. What is the next step from now onwards? First of all, whatever the program that you submitted, that program is going to split into, the program is going to split into number of executable words. And that each word is called as a token. Since the program is going to get split into number of words, executable words, since each word is called as a token, and the whole process, we call it as a tokenization. Why it has to be get tokenized? Because the SAS has been developed on C language. So when you submit that program in the backend, the program will be get executed in the C language. It has to be converted into C language. So to get executed in that way, the program should be get converted into executable C language words. There the program will be get executed. And the whole process we call it as a tokenization. Once the tokenization has been got over, now, from now onwards, we will divide the whole process into 2 important steps. The first step that we call it as a compilation phase, or some people also call it as a compilation stage. What is compilation phase or a compilation stage? And of course, we are going to have the next important step, which is called as an execution phase, or we can also call it as an execution stage. So the whole process in the backend now we can divide into compilation phase and execution phase. What exactly happens in the compilation phase? During the compilation, within the compilation phase, again, we are going to have 3 important steps. The first one, we call it as an input buffer. What you call it as an input buffer. And the second one, we call it as a descriptor area, or we can also call it as a descriptor portion. And the third one, we call it as an PDV. PDV means program data vector. Program data vector. So these are the 3 important steps will take in place. All these steps will take in place in which phase? During the compilation phase. The first one is called input buffer. The second one is called as a descriptor area or descriptor portion. And third one is called as a PDV or program data vector. And by the way, what is this input buffer? Input buffer is nothing but a logical memory area. Logical memory area. And what we can find in the descriptor portion? In the descriptor portion, we can find the metadata. We can find the metadata of a data set. The metadata of the data set. Yes. And in the PDV is also called it as a logical memory area. Do not worry about that one. I will explain that one. Logical memory area. Now we'll discuss about all these three. Okay. Now this is the program that we submitted. As I said, now when we submit the program, now what I'm not going to write here about that, like tokenization, compilation phase, or something like that one. Now first one, I will directly go to the compilation phase. I told you in the compilation phase, first what we are going to have. What is the first stage of compilation phase?
Input
Compilation phase. We are going to have input buffer. This is how input buffer looks like. Input buffer is just like input buffer is just like a railway track. This is how we are going to have input buffer. In the input buffer, what we are going to have? In the input buffer, we are going to have number of boxes. This is input buffer, okay? Now, we are going to have number of boxes in the input buffer like this one. As soon as input buffer has been created, first thing what is going to happen? Whatever the first record that we have in our program, the record will goes and joins the input buffer. Okay, tell me what is the first record that we have in our program? We have we have 101. We have 101 space. Then we are going to have A, B, C, each letter in one box. Then we have a space. After that, we have a 23 space. Then we have F space. Then we have 5000. Now this is how we are going to have input buffer. So the first record of our program will goes and joins the input buffer. And I told you, input buffer is nothing but a logical memory area. Generally, in our system where we install SaaS software, any programming language, where we install generally in the C drive. And install a programming language, any software in the C drive, we will allocate some space. In that space, it will create a logical memory area, and that is called input buffer. As soon as the first record joins the input buffer, now it will do some important housekeeping works. What is that important housekeeping works? If I execute the program, what is the data set we will get? DS1. Where this DS1 will be created? In which library it will be created?
Work library.
Now it will check. To create the DS1 data set, do we have enough space in the work library or not? Just imagine, here we have only 6 records. It is not a big thing. Just imagine, I have 10 lakhs observations. I have 2000 variables. Say, for example, to create the data set, we require, say, for example, we require 1 GB memory. So now what SAS will do? SAS will check, do we have 1 GB memory in the work library? If you have, it is okay. But if you do not have, what will happen now? The program will go for false. The program will be get false because we do not have enough memory to create a data set in work library. Isn't it? Say, when you try to copy a movie into your pen drive contains only 2 GB space, but the movie is 4 GB. What will happen now? Is it going to copying going to get occurred? No.
No.
You'll get a warning and the copying processor will be get stopped, isn't it?
Yes, sir.
In the same way, if you want to say create a data set in the work library, now it will check, do we have enough memory in the work library? If we have enough memory, then the next takes place. The next step will take place. Now what SAS is going to do now? It is going to check, okay, what are the variables that we have in the program? What are the variables that we have in the program? What are those characters of those variables? It is going to check each and everything. Now, what it is going to, it will check all that information and now it will write that information in a particular area. So of the input buffer, now it is going to create the next step, which is called as a descriptor portion, and simply I'm writing it as a DP, or we also call it as a descriptor area. What information it is going to save in the descriptor area? It will save this information. What are the variables that we have in this program? Tell me, what are the variables we have in this program?
ID, name.
We have an ID variable.
Name,
Age.
We have a name variable. We have an age variable. We have a sex variable, and we have a salary
Salary
variable.
variable.
So it is going to write all the variables information in the descriptor area now. Not only that one, now tell me, what is the data type of ID variable in the program? Numerical. ID is a numerical variable. What about the name? It is a character variable. Then the third value, age variable, it is a numerical variable. Fourth one is a sex variable. I specified the dollar symbol, it is a character variable. The salary variable, we do not have a dollar symbol. Then what is the salary variable now? Salary is a numerical variable. So in the descriptor area, it is saving the variable name, and now it is saving the variable data type. And along with that, it is also going to save the length of each and every variable. Did I specify length anywhere?
no,
No. If you didn't specify the length, then what is the default length?
8 characters.
The ID variable length is 8, the name variable length is 8, age variable length is 8, sex variable length is 8, and salary variable length is 8. So far, what information it is saving in the descriptor area? In the descriptor area, so far, it saved variable name, variable data type, and is also saved variable length. Understand this one?
Yes.
Now, what is this data? What is this information? Is this is the data? Do you think this is data?
No.
No, this is not. Actually, this is data. Okay. Now, to save the data in a table, I'm creating a table. Now, this is the table information. This is the table information. This is not actual data. To save the data, to keep the data in a place, I'm creating a table. Now, I'm saving the table data. That's why this data is called as a metadata. What do you call it as a metadata? In the real time, metadata is very, very important. Now we'll see again, what do you mean by metadata? I will give you a simple example so that you can understand what you mean by metadata. So for example, I have very candid picture of me. I love this picture very much. Okay, I have very fond memories about this picture. Now, since I like this picture very much, what I want to do, I want to keep it safe, this picture. I want to hang this one too in my drawing room. So what I will do, I will go to the photo frame shop, and I'll ask them, keep it this one in a photo frame and give it to me. Now, I strictly told them, in the back side, I want to have a metallic sheet, a quality metallic sheet. And I told them on the front side, you should have a very thin glass. It should be very transparent, very clean, high quality glass. And I told them on all the four sides, keep, a wooden strips Okay. And on the top, keep a hook so that I can hang this one to, a wall. And also I told them, keep one more, side stand so that I can keep this one, on my study table or somewhere. Now tell me, so he asked me, he called me like, he's ready to deliver that my photo frame. And then I went to that like and asked him, did you do what and all? I said, did you do according to that what are the measurements and the instruction that I have given? Did you create this? Did you build this photo frame according to my rules and or not? And he said, yes, I did according to your instructions only I did. Now, what is the proof for that one? What is the proof that he used the same metallic sheet that I asked him to? And he did the same glass that what I asked him. How I can know that one?
He will send
Now?
off the photo of the.
So now he is going to show me the bills that when he purchased that metallic sheet, the glass and the wooden strips or like hook or a stand. He's going to show me all those bills. Now tell me, in this, what exactly is my data? What exactly that, that is not relevant here? Actually, the most important thing is my picture. Isn't it? Now to save this picture, I asked him to create a frame according to my wish. Now, the Photoshop person is going to keep all that information in one place. And when I went there, he showed me, this is what I used. This is the material that I used. And he showed all that information. That metallic sheet information, that glass information, that whatever the wooden strips information, that is not actual data. Actual data is my picture. Isn't it? Now, this information, whatever the information that we have, and this we call it as a metadata. Understand this one? The actual data is my picture. To save my picture, to keep it my picture very safest way, very protected way, I am creating a photo frame. I am saving that photo frame information. So photo frame information, not exactly what I needed, but to keep my data, my picture in a safest manner, we are using that material. I am saving that material information. Understand this one? So whatever the photo frame material information that we have, that we call it as a metadata. In the same way, to keep all these 6 observations in a place, I'm creating a table. Now I'm saving all the table information. What do you mean by table? Table is nothing but few variables. What do you mean by variable? Variable name, variable data type, variable length. So far we know these 3 important things. In future, we are going to discuss about the variable label. We are going to discuss about the variable in format. We are going to discuss about variable in format, and we are going to discuss about variable format. But these six characteristics are called variable. These 6 things are called metadata. Give me 1 second. Okay. Understand this one? Now I'm keeping that whatever that variable information that I have, I'm keeping that variable information one place. That is the descriptor portion. Now what is this variable information? We call it as the variable information we call it as metadata. In the real time, metadata is very, very important. You know why it is important? I asked you to create a table, and I asked you, I want to have these variables. I want to have some variables are numerical, some variables are character. I want to have particularly this much length. And you created a table. How do I know that you created this table according to my requirement or not? How we can understand, when you write an exam, am I going to give out of 100 marks? No, I need to validate it. I need to check whether you have written correct information, whether you have given correct information or not. In the same way, when you create a data set, how do I know that you created this data set according to my requirement? So now I'm going to look into metadata. When I look into the metadata, I will come to know that one, what are the variables that you created, what are the data type that you used, what is the length that you used, what is the label that you used in format and format. After checking all this, if this information is equal to my requirement, then I will pass this data set. Then your task will be get completed. Then you will be get assigned for another task. That's why in the real time, metadata is so important. Data ante important, metadata kuda ante important. Understand this one, everybody? How much data is important? Metadata is so that much important in the real time. Clear, everybody? So where we can find this metadata? We can find the metadata in the descriptor portion or descriptor area. What do you mean by metadata? Metadata is nothing but, so far you know variable name, variable data type, variable length, and what are the other things that we are going to have? Variable label, variable in format, and variable format. You don't know about the label, in format, and format yet. From maybe, hopefully, from day after tomorrow onwards, we are going to discuss about this metadata. Clear, everybody? Now, once you're done with the metadata, descriptor area, next we are going to have third most important thing is descriptor area. Sorry, the third most important thing that we are going to have is PDV. Now, how this PDV looks like? You know, this is how, sorry. This is how the PDV looks like. The PDV, we are going to have like an boxes. This is how PDV looks like. We are going to have number of boxes. So in the PDV, we are going to have a number of boxes. We are going to have one box for each variable of our data, our program. In our program, what are the variables that we have? We have an ID variable. Okay, we have an ID variable. First, we are going to have, ID variable. We are going to have ID variable. What the hell is this? Yes, ID variable. Then we are going to have name variable, one box for the name variable. Then we are going to have age variable. Then we are going to have sex variable. And then we are going to have a salary variable. Okay. And apart from that, ID variable is a numerical variable. Remember, the numerical variable is going to have a period symbol. Name is a character variable. By default, we are going to have a blank space. Age is a numerical variable. We are going to have a period symbol. Sex is a character variable. We are going to have a blank space. Salary is a numerical variable. By default, in the starting, we are going to have a period symbol. And you know that ID is a numerical variable. N, name is a character variable. Age is a numerical variable. Sex is a character variable. Salary is a numerical variable. And all the variables by default length, we haven't specified any length. So by default, all these variables length is 8. And this is called PDV. What do you mean by PDV? What is the full form of PDV? Program data vector. Sorry. In the PDV, along with the variable that you specified in our program, we are going to have other two important variables. You know, what are the other two important variables that we are going to have? We are going to have the first important variable,
OBS.
So we are going to have the first important variable, which is called underscore error underscore. This is an automatic variable. This is what we are going to have in the PDV. And along with that underscore error underscore, we are going to have one more automatic variable, which is called underscore n underscore. These two are automatic variables. These two are automatic variables. And we are going to have these two automatic variables here. We are going to have two automatic. These two are automatic variables. These two are automatic variables. So that's why what is going to happen now? These two variables will be get dropped. So will be get dropped in PDV itself. Here we are going to have drop option, and here also we are going to have drop option. And remember one thing, at the starting, underscore error underscore is going to have value called 0, underscore n underscore in the starting we are going to have value called 1. And this is called PDV. This is now end of compilation phase. Now tell me one more time, by the end of the compilation phase, what is the situation? Where we have our first record of the program? Right now, where we have our record? Our record right now is present in the input buffer. What we have in the descriptor area? In the descriptor area, we have a metadata. Variable information metadata. And what we have in the PDV? In the PDV, each variable is going to have one box. Along with that variable that you specified in our program, we have extra two automatic variables. What are the two automatic variables that we have? Underscore n underscore, underscore n underscore. What is that underscore n underscore? In underscore n, error underscore, at the starting, we are going to have a 0. Okay, we are having a 0. At the starting, underscore n underscore is having a value 1. Okay, we have 1. And all the numerical variables are going to have a period symbol. All the character variables are going to have in the PDV blank space. Now, this is the situation at the end of the compilation phase. Once the compilation phase got over, now the next step will take place, which is called execution phase. Could you able to follow everybody? Everyone?
Yes, sir.
Now, what is execution phase? How is execution?
Appears in log window, sir.
Automatic means it will be get created only in the backend.
Okay.
You cannot see those in the data set.
Okay.
Yes.
Sir, 0 and 1, that value at the starting only, or each and every observation it will show?
So far, we know at the starting, this is the situation at the end of the compilation phase. Okay. Now we'll say what is going to happen during the next step is execution phase. Now we'll say what exactly happens during the execution phase. Clear, everybody?
Yes, sir.
Now, during the execution phase, now the program will be get executed. How this program is going to be get executed? That we'll discuss now. You know, anybody of you, did you cast your vote at any time? Did you cast your vote in any general election?
Yes, sir.
Yes, sir.
How we cast our vote? Any idea?
Pressing button.
No. when you go to the polling station, just imagine this is the polling station. Okay. Now first, you will enter the polling station with your voter slip. What you will do, first you will go to the polling officer P1. What the polling officer will do now, the polling officer will check, if you have whether you have that vote in the voters list or not. Isn't it? First he is going to check. And after that he is going to check your validity, whether you have that proper identity, government issued identity proof or not. So that is that work of the first polling officer P1. And if you think that you have a vote, your name is present in the list, and whatever that identity proof that you supplied, it is authentic, then after that you will approach to the second polling officer. Now he will take a signature from you and he is going to hand over the ballot paper to you. Now you will go to the third polling officer. The third polling officer is going to give the stamp to you and he is going to put an ink mark on your, maybe middle finger of your left hand. Then after that, you will go to the secret area. Now there you are going to cast your vote and you are going to fold that ballot paper and you will come out of that secret area. Now you will go to that fourth polling officer and now he is going to have the ballot box. Now we are going to put our vote in that ballot box and then after that you will go get out of the station. Isn't it? Say for example, today, 1,000 voters, they are going to cast their vote in this polling station. Now all the 1,000 voters will do the same cyclical steps. First, they'll go to the first polling officer. Then they'll confirm that vote. Then they'll go to the second polling officer. They'll put a signature and they'll take the ballot paper. Then they'll go to the third polling officer. He's going to put an ink mark and he's going to give the stamp. Then he'll go to the secret area. You'll cast your vote and you'll come out there. You'll put the vote in the ballot box and then you'll go to the out of station. You cannot go in between, in the middle, and you cannot come backward or you cannot go forward. You should always do in the same cyclical order, isn't it?
Yes.
So now, if one voter is interacted by each polling officer one time, if you think that is one cycle, how many cycles are going to take place today in this polling station?
1,000 cycles.
Because we have 1,000 voters, so 1,000 cycles will take place, isn't it? Now, coming to our program, just imagine each polling officer is one statement. Okay? And each record is the voter. In our program, we have 6 records. That means we have 6 voters. Each record goes and communicates with each statement one time. So just imagine one statement is one polling officer and one record is one voter. Just coming to again our example, our data set. This is the back-end, compilation phase. By the end of the compilation phase, this is the situation that we had. Clear, everybody? Now, what is going to happen now? What is the first statement that we have? Sorry. What is the first statement that we have in our program?
Data statement.
Data statement.
Data statement. Data DS1. That means in the backend, what it will do now? Now it will create, data DS1. In our program, we have a data DS1. That means now it will create a data set now. Where it will create data DS1, where the data will be get created? The data will be get created in the work library. Okay. Now, so we have our first record in the input buffer. Now this record will be get executed by each statement one time. So data DS1, it will create DS1 data set. Then what is the next statement that we have in the program? Input statement. In the input statement, what is the first variable that we have?
ID.
Now it will start in the backend like this one. Okay. We have, what is the rule I told you? Space or 8 characters, whichever comes first, it will stop there. Now it will start here. 1, 0, 1 space. Now this 101 will go to which variable now? This 101 will go to ID variable in the PDV. Understand this one? It will go to the PDV. It will go to PDV. And after that, now after the space, again we have A, B, C space, A, B, C space. Now A, B, C will go to which variable now? What is the second variable that we have in the input statement now?
Name.
Now this A, B, C will come into name variable in the PDV. Now after the space, again we have a 2, 3, 23. Now the 23 will come into, from the input buffer, it will come into PDV. Is. After the space, we have F space. F will come into which variable now? F will come into sex variable in the PDV. And after that, we have space 1, 2, 3, 4 digits. Now 5,000 will come to which variable now? The 5,000 will come into salary variable in the PDV. So now it read that input statement. So each value will go to one variable in the PDV. Now after that input statement, data lines is only for to tell it is any stream data. After the input statement, next statement, can you say what is the next statement that we have? Run. But before the run, by default, we are going to have a statement called output statement. Default, if you are not writing also, by default, we are going to have an output statement. You know what this output statement will do? That output statement, just like in a printer, it will write that observation. Right now, where we have our observation? Our observation came down from the input buffer into PDV. Now, as soon as observation moved into PDV, the input buffer will be get cleaned out. It will be get washed. So now the input buffer is free. It is an empty. Now, right now, we have our record in the PDV. Right? Now, why before the run, we have an output statement. Now, what this output statement will do, this output statement will write the observation from PDV into the data set. Now, in the PDV, we are going to have an ID variable. Then we are going to have a name variable. Then we are going to have an age variable. Then we are going to have a sex variable. And then what is the next variable that we are going to have? Salary. But you will not have underscore, error underscore, because these two are automatic variables. So these two will be get dropped in the PDV itself. Now tell me in the PDV right now, what are the values that we have? We have 101 in the ID, name ABC, age 23, sex F, and then we are going to have, what we are going to have for that one? We are going to have salary 5,000. When the observation moved from the input of PDV into the data set, now the PDV will be get cleaned out. PDV will be get washed. Now the PDV will become empty. Now, do we have any errors in our program? No errors. So error underscore is going to be keep only 0. Now the first cycle is over. Now it is ready for the second cycle. Now n underscore is going to become 2. Yes, somebody is asking something.
Sir, when there is no use of error and underscore n dash underscore means n underscore, then what is the use, sir?
I will tell you what the use of that one.
Okay, sir.
Okay.
Okay, sir.
Sir.
Yes.
So why
you have extra data? It's going to. Hello.
Yes, Badri.
Sir, when we have extra records in the first record, I mean extra data after salary, is it going to be placed?
No, it will be get ignored. No error. It will be get just ignored.
Okay.
Now the first cycle over. Suddenly in the first cycle, what happened? The first observation came to input buffer. From the input buffer where it entered to the PDV. From the PDV where it will go? It gone into the data set. Now, if an observation moved from input buffer into PDV, from the PDV it goes to the data set, and that we call it as a one cycle. And in technical terminology, we call it as a one iteration. What do you call it as a one iteration? And people call it as an iteration, but you should call it as an iteration. Iteration is nothing but a cycle. What do you mean by cycle? If each record is executed by one statement one time, and that we call it as a one cycle. Now tell me what is going to happen. Now the second record 102 space DEF space age 27 space gender male space salary 9,000 now will come into input buffer. Now this record will be executed by one statement at a time. One time. Again data DS1. Yes, we have a DS1 data set. Now input. So I told you space or 8 carry whichever comes first 102 space 102 will come into PDV ID variable. After the space DEF. Now the DF will come into name variable. After the space 27 will come to age variable. Space M will go to sex variable. After the space 10,000 or 9,000 will go to salary variable. Now again it will come to output statement. Output statement will write the observation into the data set. Now we are going to have 102. We are going to have a DEF 27 male 9,000. Now what happened now? The second observation, first it went into input buffer. From there it came to out PDV. From the PDV again it entered into data set. Now this is called second cycle or second iteration. As I said, when the observation moved from input buffer into PDV, input buffer will be cleaned down. And when the observation moved from the PDV into data set, again what is going to happen in the PDV? The PDV is going to be get washed out. It is going to be get empty. Now it has become empty. All the numerical variables again is going to have all the numerical variables will have a period symbol. All the characters is going to have a blank space. In this way, each observation, first it will go to input buffer. From that it will come into PDV. From that it will enter into the data set. And if an observation moves in that way, each one is called one iteration. For each iteration, underscore n underscore value is going to be get incremented by +1. For the first observation, underscore value will be 1. For the second cycle, second iteration, underscore n underscore will be get incremented by +1, so it will become 2. For the third iteration, it will be get incremented by +1, so it will become 3. In that way, since we have 6 observations, after the 6th observation, what is underscore n underscore value will be 6.
Sir?
Yes.
Sir, by that we can say that number of iterations is equal to number of observations?
Yes. Number of observations is equal to number of iterations. Because each observation is moving from input buffer into PDV, from the PDV into data set, that is called one iteration. So one observation, one iteration, 2 observation, 2. So if you have a 10 observations now, how many cycles will take place now? 10 cycles.
10.
So 10 iterations. So the number of observations is equal to number of iterations. So for the first iteration, what is underscore and underscore value? 1. For the second iteration, it will be 2. Third iteration will be 3. And so on and so on.
ఎన్ని అబ్జర్వేషన్స్ ఉంటే
అన్ని iterations జరుగుతున్నాయి.
And in error, when there is a error, that time it will show the value, right, sir?
Well, if you do not have any error, all the time, what is underscore error underscore value? 0. When you have an error, then underscore error underscore is going to become 1.
Okay.
Understand this one? Now I'm going back to the program. Yes.
It means in one statement, suppose one observation, 2, 3 errors are there. So it
How
will
many
show
errors that we have? Still, the underscore error underscore value will be 1.
Okay.
I will show you. Okay. Now this is my program. Yes.
Sir, before beginning of the compilation phase, these automatic variables gets automatically generated.
No. During the compilation phase only, during the PDV creation, it will create automatic variables. Okay.
During PDV phase, sir?
When the PDV will be created during the compilation phase.
Okay.
Okay. Now, tell me, do we have any error in this program? No. No error at all. So in the log window, we cannot find any information. Now see, wantedly, I'm committing a mistake here. Generally, after the name, what we should write? $symbol. Because we have a character data, right? But I didn't write the $symbol. So that means according to this program, name is a numerical variable. isn't it? And the data we are getting
Correct.
character data. So you know that a numerical variable cannot read character data. So now this is a logical error. This is not a syntax error. Syntax errors means what? Semicolon error or spelling mistake. Now see, I'm trying to execute this program. You know what is going to happen? You will not get the data in the name variable. Now we are getting, can you see what we are getting in the name variable? We are getting a period symbol. I will tell you why we are getting a period symbol in a minute. Now I'm going to the log window. Now we can see, we can find lot of information. And by the way, I told you we are going to have input buffer in the back end. This is how input buffer looks like. Now, since we have an error, can you try to read this note?
Invalid
The name in line 27, 5th column to 7th column. 5th column. Why this 5th column? This is, say, for example, 1st column. Okay. 2nd column, 3rd column, 4th column, 5th. Sorry. Now this is a 5th column, 6th column, 7th column. So from 5th column to 7th column, we have invalid data. Why it is invalid data? Because the name is a numerical variable, but the data is character data. So it is invalid. So that's why in the log window, this is our first record, but 101 will go to ID. Can you see what we have in the name variable?
Period symbol.
You know why period? I told you in the PDV, all the numerical variables, so by default, what it is going to have?
Period.
So since I'm not adding a since I'm not adding a dollar symbol according to the PDV, now what we are going to have in the name variable for name variable in the PDV? Period symbol. Because I specified it's a numerical variable, but the data is character data. It couldn't able to read. That's why we are getting a period symbol, because according to this program, name is a numerical variable. Understand? Now I have an error. Since we have an error in the log window, can you see underscore error underscore is going to become 1. I told you first record, first iteration, first observation. So what is underscore and underscore value? 1. So second observation, second iteration 2. Since we have a 6 observations, so 6 cycles, 6 iterations, underscore and underscore is from 1 to 6. And but in each observation, we have error. So that's why underscore error underscore is going to be 1. If we do not have error, underscore error underscore will be 0.
Okay. Sir, any errors in the one error and data?
Yes. Now I'm going back to the program. I'm committing one more mistake here. Actually, sex is also getting the character data, right?
Yes.
But here also, I am specifying it as a numerical variable. That means in one record, how many mistakes I committed now?
2.
But still, even though I committed 2 mistakes, in the log window, what is underscore error underscore value that we have?
1.
No matter how many errors we have in one record, so underscore error underscore value will be 1. If you do not have any error, it will be 0. But if you have an error, it will be 1. Understand this one so far? Is this clear?
Yes,
And we are running out of time. Can we continue tomorrow's class?
Sir, small doubt.
Yes.
Sir, earlier you said one option to not visible this error and error underscore error and square n underscore.
Yes. No list option. No list option. If you specify no list option, this information will be get suppressed in the log window.
Okay. That should be mentioned in the data lines, right, sir?
No, in the data statement.
Data statement.
Here we should write the no list option.
Okay.
Okay.
Yes, clear.
Sir, the automatic variables, I mean error and underscore
Yes.
error log window lo appear aina came problem undadu. So just
No, you should not have that one. If you have an error, you have to rectify that one.
Okay.
How to rectify that one?
Error 0 only, I mean normal iteration values unna sare automatic variables avasar leda sir log window lo
See, when you do not have any error in the log window, you cannot see those 2 variables, because I told you both the variables will be get dropped in the PDV. See, when I'm not having error, can we see those variables? No. Only those 2 automatic variables will be get displayed when you have only error. Understand?
Sir, can you please explain? The data is coming from input buffer direct into PDV. Then what is the role of descriptive area?
Descriptor is going to save only that metadata. Metadata means it will save the variable information. What are the names of variables, data type of the variables, length of the variable, format, labels of the variable.
Sir, but that is also coming in the program data vector also.
Once it has been created, that's it. That information is going to get stored. But every time the observation will move only from input buffer into PDV to dataset. But this area, it is going to save the metadata, that's it. Once it has saved the metadata, that work is over. There is no involvement of descriptor area now onwards. It is going to store only the metadata.
Okay, sir.
Okay. Clear, everybody? Do not worry. If you have any doubts, we'll discuss that in tomorrow's class. Okay, I'm running out of time. I need to take another class. Okay? Okay, guys. See you in tomorrow's class.